Welcome to the Bentley Systems training course, where we will discuss topics about how to push a RAM structural system building model to the iTwin Analytical Synchronizer. In this particular video, we will create our new iTwin repository from an analyzed RAM structural system building model, including reviewing the push settings, specifying the deck and slab mapping, and choosing which objects will be pushed from RAM structural system to the iTwin Analytical Synchronizer. Now, before we begin, let's first discuss the advantages of using the iTwin Analytical Synchronizer in your workflow. Bentley's analytical iTwin technology, formerly referred to as Integrated Structural Model, or ISM, is developed for sharing engineering project information amongst modeling, analysis, design, drafting, and detailing applications. iTwin technology is similar to building information modeling, but it focuses on the information that is important to the analysis, design, construction, and modification of infrastructure assets. Now, there are two main purposes for using the iTwin technology. The first is to transfer or synchronize engineering information between applications, and the second is the coordination of engineering information between applications and project stakeholders. We will now turn our attention to our building structure in RAM structural system. As you can see, this structure was created in the RAM modeler, and steel and concrete members were already analyzed and designed. We are now at the point in our workflow where we are ready to create the iTwin repository. To start that process, click on the iTwin Services icon in the RAM Manager. The iTwin Services dialog will now be docked at the right-hand side of your screen. The iTwin Services will allow you to access two modes of synchronization, cloud and file, and these can be selected as you're creating your repository. Using the file-based workflow, this will allow you to synchronize your model locally. Alternatively, if you want to use the cloud-based workflow, this will allow you for synchronization to an iModel on ProjectWise 365. This workflow will allow access to some additional cloud-based functionalities, such as the analytical design review and issues resolution. For this particular playlist, we're going to synchronize our model locally and review the pushed information in the iTwin Analytical Synchronizer. So let's go ahead and select the file option. The next thing we're going to do is decide which file to synchronize to. To do that, you can go ahead and click on this option here. So to set up your local synchronization, you can select an existing ISM model or create a new one. For this exercise, let's go ahead and create a new ISM repository. We're going to be asked where we would like to save this file, and we can go ahead and name it. Automatically, the program will add the .ism.dgn extension to this file. Once we've selected our ISM local repository, let's go ahead and click on the Confirm button. Now, before I send any data from any of the applications to the iTwin Analytical Synchronizer, I do like to review the settings. So let's go ahead and click on the Edit Settings option. The first thing we're going to see is our model offset settings. This will basically be where do you want the origin of your model from RAM structural system to be when it goes to the iTwin Analytical Synchronizer. Now, if the origin of your model belongs at 0, 0, 0, you can just leave these set to their default. We also allow you to specify a rotation. Let's go ahead and scroll on down. Now, when you are pushing a model from RAM structural system to the iTwin Analytical Synchronizer, you do have some setting options about whether or not you want to push loads or also reactions to that repository. So this first option is export gravity loads. This basically means that any loads that were specified in the RAM modeler as superimposed loads, whether they be surface, line, point loads, or snow loads, will then export to your synchronizer, and they will be available for being pulled into another application. I'll go ahead and select this option. Now it should be noted that any of the forces determined from RAM frame will not export to the iTwin Analytical Synchronizer. Let's go ahead and scroll on down, and we can see that we also have the option to export beam reactions. These will be the reactions at the end of your gravity beams from the gravity load distribution. So if we go ahead and say export beam reactions, the reactions will export from RAM structural system to the iTwin Analytical Synchronizer, and we have the option to say whether or not we want to export or push the factored reactions or unfactored reactions. I'm going to go ahead and push the reactions in their unfactored format, and I also have an option to say the minimum exported beam reaction. So I'm going to say anything that's less than 6 kips, go ahead and export or push as 6 kips. Okay. In addition to that, let's go ahead and scroll on down, and we can also choose how many decimal places or significant digits we would like to observe. I'm going to go ahead and say 0. The final thing we're going to take a look at within the settings is with regards to the reinforcement. Now, if you have done any concrete detailing, whether it be from RAM concrete or RAM foundation, that reinforcement is a candidate for being pushed to your iTwin Analytical Synchronizer. This particular model has concrete beams, concrete columns, and concrete walls. It also has some concrete rigid foundations, all of which were designed within RAM structural system. So I'm going to go ahead and export that reinforcement. So let's go ahead and return here. Now the last thing I'm going to do is I'm going to just take a look at the databases I used for my steel design and make sure it's mapped the way I would like it to be. To find that option, let's go to the File menu, and we're going to find this iTwin directory. Here I can select my iTwin Analytical Synchronizer defaults. What I'm interested in looking at, though, is this master table mapping. So whenever you set up a RAM structural system model, particularly one that has steel structures within it, you're going to select a master steel table. For this particular model, I'm using the RAM AISC master steel table. What I can do now is I can go ahead and map that table to a standards organization, and I'm going to go ahead and select the AISC. You can see here for each of the different master tables we have available by default in the program, we can go ahead and map them to a standards organization. Once we're done with this option, let's go ahead and click OK. Now we are now ready to go ahead and push this model to the iTwin Analytical Synchronizer, and we are going with a local workflow for this video. Let's go ahead and click on the Push to File option. Now when we push the model to the file, we have the option to show change management. What this option does is it allows you to go ahead and select which items you want to push manually versus not. If you leave this option unselected, it means everything that's a candidate for being pushed to the repository will automatically be pushed for you. I'll go ahead and say Show Change Management for this exercise. Now let's push our model. Once the push is initiated, RAM Structural System will ask you if you want to specify any mapping information, particularly if you have any composite or non-composite deck systems specified in the RAM modeler. For this particular model, we have a composite deck system on the 3rd floor and a non-composite system on the roof level. Let's go ahead and start with the composite deck. I'm going to select this deck and click on the Edit button. If I want to associate this deck with a deck that's recognized by the iTwin Analytical Synchronizer, I'm going to unselect the No Mapping option. Then I can select the organization of the decking system. I could also select the profile and the thickness of the deck. Once I enter this information, we can go ahead and click OK, and we'll see that the iTwin steel deck has now been specified, and this will successfully export to the iTwin Analytical Synchronizer. Now, the roof deck information, let's go ahead and select that option. I'll click on the Edit button again, and I'm going to go ahead and map the roof deck as well. Now, before I exit out of the Mappings dialog, I'm also going to take a look at the Operation Settings. This is another way where you can customize how your model will be exported to the iTwin Analytical Synchronizer. You can go ahead and specify your node generation information and also your coordinate options. In addition to that, let's go ahead and take a look at this column splice information. Now, if your story data in the RAM modeler contains column splices, you can go ahead and enter the height of the column splice above the story level upon pushing your model. In addition to that, you can also specify your cantilever extensions and whether or not you want to lower beams that are supporting only steel joists. For my particular model, I'm going to go ahead and lower the beams supporting steel joists only by 3 inches. Once I'm done, let's go ahead and click OK. Now, if you selected the option for Show Change Management, the iTwin Analytical Synchronizer will appear on your screen or in the taskbar on your computer. What this will do is it'll allow you to go ahead and select the options or the items or elements that you want to send to your iTwin repository. So let's go ahead and take a closer look at our iTwin repository. Now, ISM is not intended to store all of the information of its client applications. Rather, it's intended to store and communicate consensus view of data that is common in 2 or more of its applications. All of the objects within the iTwin Analytical Synchronizer will be organized by their different functions, and you can go ahead and filter and select which options you would like to go ahead and select. In addition to that, you can also select any type of element on your screen to review further information in the Properties area. In the next series of videos, we'll go ahead and review some of the imported information a little further. To finish off our workflow, though, for this video, we'll go ahead and accept all of the changes to review how a model would automatically come in to the iTwin repository from RAM Structural System. So to complete our step, let's go ahead and say Select All, and we will accept all the changes. That means everything that we have sent from RAM Structural System will now exist in the repository. To finish this off, we can click on the Update button, and we can enter a message. The message can help you track the progress of your project. So here I'm going to say repository created by RAM Structural System. I'm going to flag this as a major change, and then we'll go ahead and click OK. After the iTwin repository is officially created, we'll be able to see whether or not our model from Structural System was pushed successfully. For this particular model, it seems like our push was successful, so we can go ahead and complete that operation. Now at this point, if I make any changes within RAM Structural System, I can go ahead and push those changes to the file, and it will automatically be linked to the file that I chose to synchronize to. At this point, this completes my process for creating an iTwin repository from an analyzed RAM Structural System model using the local file workflow.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.